Welcome to The Explainer. Today, we are digging into a topic that really separates the tech giants from the flashes in the pan: system scalability. We're going to explore how a system can go from just one user to millions without completely falling apart. Let's get right into it. So imagine this. You launch an app, and somehow it goes viral. Like, overnight. Users are flooding in, social media's absolutely buzzing, and then it happens. Your site slows to a crawl. And then it crashes. That amazing moment of triumph turns into a total technical nightmare. It's the kind of problem every developer dreams of having, and at the same time, completely dreads. It's a problem of success, and the only solution is scalability.
So how do you prepare for that viral moment? Well, the answer is scalability. And it's not just about handling more traffic. It's really the art of graceful growth. It's all about designing a system that can expand intelligently and efficiently so that nothing breaks when it's under pressure. So what is scalability really? At its core, it's a system's ability to handle a growing amount of load. We're talking users, data, requests, gracefully. And that word gracefully is so important. It means your performance, things like your response times and your error rates, they stay stable even when you suddenly get very, very popular. Okay, so when you realize you need more power, you face your first big fundamental choice. Do you build up, making one single machine more powerful, or do you build out by adding more machines to your fleet? This one decision between vertical and horizontal scaling is going to define your entire architecture. So here's the high-level breakdown. Vertical scaling, or scaling up, is kind of like swapping the engine in your car for a much bigger one. You're just making a single server more powerful with more CPU, more RAM. Horizontal scaling, on the other hand, or scaling out, that's like adding more cars to your fleet. You distribute all the work across many, many servers. And right here, the trade-offs become crystal clear. Look, vertical scaling is simple to do, but it gets incredibly expensive. And pretty soon you hit a hard physical limit on how big one machine can get. Plus, and this is a big one, you're creating a single point of failure. If that one super server goes down, your whole system goes down with it. Horizontal scaling, on the other hand, yeah, it's more complex to set up, but it's way cheaper, has virtually no limit, and it's incredibly resilient. If one server fails, who cares? The others just pick up the slack. For any kind of massive growth, scaling out is really the only way to go. Okay, so we've made our choice. We're going to scale out. But that creates a brand new problem, right? If you have dozens of servers, how do you decide which one gets the next user request? You need some kind of traffic cop. And the component that plays this traffic cop role is the load balancer. It's this brilliant piece of tech that sits right in front of all your servers. When a request comes in, it intelligently routes it to an available, healthy server. This prevents any single machine from getting overwhelmed, and it's what allows a whole fleet of servers to act like one single, super powerful system. But, and this is a huge but, for a load balancer to work its magic, your system has to follow one golden rule. Your application servers must be stateless. This is, without a doubt, the single most important concept for successful horizontal scaling. So what on earth does stateless even mean? Well, it just means the server doesn't hold on to any client-specific data between requests. Any server in your fleet can handle any user's request at any time. This makes scaling trivial. You just add another server and you're done. The opposite, a stateful service, is a total nightmare to scale because a user has to be stuck to the one specific server that holds all their session data. So you've scaled your application servers, you're handling millions of requests, everything's great. But soon, a new problem starts to show up. All of those stateless servers are now hammering one single stateful component, your database. You haven't solved the bottleneck, you've just shifted it. And this is what it looks like in practice. Your web server CPU usage is nice and low. You have plenty of them, after all. But your single database CPU, oh man, it's pegged at 100%. It has now become the new bottleneck, the new single point of failure, and the main thing stopping you from any more growth. So how do we scale what is often the hardest part of the whole system? Well, we have a toolkit of strategies. We can create read replicas. These are just copies of the database that only handle read requests, taking pressure off the main one. We can use caching to store frequently accessed data in memory, avoiding the database completely. And for extreme scale, we can shard the database, which basically means splitting it up into smaller, more manageable pieces. Of all of these strategies, one of them gives you the most dramatic performance improvement for the effort involved, and that's caching.
To really understand why, we need to talk about the insane speed differences between different parts of a computer system.
All right, let's look at the numbers. Accessing data from RAM, which is where a cache lives, takes about 100 nanoseconds, okay? That is blindingly fast. Now, let's say the data isn't in that RAM cache, and we have to read it from a fast, modern, solid-state drive. That takes about 100 microseconds. We are already 1,000 times slower than just accessing RAM. And finally, a typical database query. That's going to take you around 1 millisecond. That is 10,000 times slower than getting that same data from a RAM cache. Let that sink in. 10,000 times. And that is why caching is so powerful. It serves data at lightning speed, protecting your slow database from the vast majority of requests.
Whew, okay, we have covered a ton of ground, from that very first server to load balancers and all these database strategies. Let's consolidate all of this into a quick, actionable playbook.
So here's your cheat sheet. You start with vertical scaling. It's easy, but it's limited. For real growth, you move to horizontal scaling, which is all made possible by a load balancer. Your biggest performance win is almost always going to be caching. To scale your database reads, you add read replicas. For massive write loads, you eventually turn to sharding. And to speed up content delivery to users all around the world, you use a CDN, or a content delivery network. Each one of these is just a tool you add to your belt as you grow. And let's end on a really crucial piece of advice, something you'll hear in pretty much every system design interview: don't over-engineer. Always start with the simplest solution. A single server is perfectly fine when you're starting out. Then you evolve, justifying each new piece you add, the load balancer, the cache, the replicas, with real data and estimations. The question isn't just, can you build a massive system? It's, can you build the right system